location of the point, and you're adding the second weight, but the second weight is multiplied by the location of the second point. And then you're dividing by the weights added together, because when you find the average or the mean of something, you add something together and then you divide by that, okay? So this sounds really confusing. It looks really confusing. It is not terrible. So this is what we're going to be doing today. And then tomorrow, we're going to do it on, actually, we're going to do it today, I'm sorry. Today, later on, we're going to do the same thing. We're going to find X first, which is literally the same exact formula as right there. And then we're going to also find Y. This is a line. This is a graph. So you have two values that you have to do. You have to do X and you're going to have to do Y. Okay. So for number one, let's start by reading the directions. It says find the coordinates of P that represent the weighted average for each set of points on the given number line with the provided condition. So number one, point B has a weight of 2. So right underneath B, I'm going to put its weight. So I'm just going to call this weight 1 because that is the first thing I read in the sentence. The second thing says point A has a weight of 3. Because that's the second thing I read in the sentence, I'm going to call this weight 2. And then I have to find the average weight, which is P, whatever that point is. So other than just the weights, what's provided on the graph is where they are actually at. Because I called this point 1, I'm going to also call the weight 1 your X1. So where is B actually on the graph at? -7. And then this one is going to be X2. Where is A at? 2. So what I'm going to do is, because A has a heavier weight, realistically, the point that I find should end up closer to A than B because A weighs more. So I'm going to plug it into my formula. So the first thing in my formula is weight 1, which is 2, and I'm multiplying because they're right next to each other. I'm multiplying by where it is at. So I'm doing 2 times -7. And I'm adding weight 2 times where it is at. So I'm using my weight and I'm multiplying by its location. So I'm doing 3 times 2. And then I'm dividing by the weights added together. So what two numbers am I adding together in the denominator? 2 and 3. So let's multiply this. 2 times -7 is nice. I'm adding what? 6, because I'm multiplying. And then I'm dividing by what? 5. So -14 plus 6 is -8. And then I have -8/5. And this is why normally I don't like to leave it as a fraction, because we have to plot this on the graph. And you're like -8/5, like what is that? So let's divide it and just get a decimal. -1.6. So this is where P is at on my graph, which represents the weighted average of the line. So we're going to plot that. That's between -1 and -2. It's technically a little bit closer to -2, but don't think too hard. Don't hurt your brains. Okay. And if you look at your graph, that makes sense because it said A had a weight of 3, B has a weight of 2. So it should lean more towards the heavier weights. Okay, let's try number 2. So number 2, we're going to do the same thing. We're going to kind of write underneath our graph, just kind of visually. I think it helps you plug in the numbers. So let's just read our sentence. It says point C has a weight of 5. So under C, I'm putting the weight. So I'm just going to call this weight 1. It doesn't really matter which one is X1 and X2. You just it doesn't matter because either way you're going to add it together. It says point D has a weight of 2. So which one's heavier? C. So when I calculate this, it should end up closer to C because this weight is heavier. And then I'm going to write the locations for these points right underneath it. So X2 is at 1 and X1 is at 8. So I'm going to take these values and I'm going to plug it into my formula. So my formula is up at the top. I'm doing weight 1 multiplied by where I'm at. So my weight is 2. I'm multiplying by my location, which is 1. I'm adding weight 2. Nobody even called me out for that. I wrote it technically wrong. Because I listed mine as weight 2 and x2, and this one's weight 1 and x1. But does it technically actually matter? No, because either way, you're going to end up adding them together. If you want to change it to 5 and 8 here and 2 and 1 here, either way, you're going to multiply and add it together. So it doesn't matter. Okay. So let's put 5 and 8. It's not a big deal. In the denominator, what two numbers am I adding together? 2 and 5. So I'm adding my weights together. So 2 times 1 is 2. And then what's 5 times 8? 40. And then what is 42 divided by 7? 6. So that's where P is. So plot that on your graph, and then it should make sense with your weight of how heavy. So C is a weight of 5, where D is a weight of 2, so it's heavier. So it should be closer to the heavier point. So that's my P. So try number 3. It doesn't really matter which one's x1 and x2, as long as the weight goes with the correct number. It doesn't matter what order you write it in, because either way, you're going to add them together. Yes. Um, 4 times 1 is not 9. You thought it was a 4? Yeah. But you thought it was 9 if I think it's 7. Negative 16 plus 4 is not 97. So you don't need to feel like you wrote your 4, it looks like 9, and then you added 9, but you thought it was 4. You knew this, but everything still did, you never. Yes. And is it positive or negative? Yeah. Okay. Yeah. That's good. Nice, nice, nice. Mm-hmm.
On number 2,
Mm-hmm.
you put weights as 2. So why did you put both?
Like, because whenever I accidentally wrote these in, this is what I was saying earlier, is like, this is supposed to be weight 1 and x1, which would be 5 and 8. But I wrote 2 and 1 because 2 and 1 would really go here, but it doesn't matter because either way, you're multiplying these numbers together and these numbers together, and then you're adding them together. So yes, I plugged into the formula wrong, but it means the same thing because you're going to multiply and just add them together anyways. Because it would have been 40 plus 2. Instead, it's 2 plus 40. But it gets the same thing. So why it doesn't really matter which one is x1 and x2. As long as you have the weight with the proper point, the formula will still work out. The only thing you can't switch is like the weights can't be with opposite points. Okay. So you should get negative 16 plus 4 divided by 6, which is negative 12 divided by 6. So you should get negative 2. Did we get negative 2? Do we like this better than partitioning? Yes, it's way better. And we're like, this makes sense. Okay. Make sure you put it on your graph. Negative 2 is here. Your weighted average should never fall outside of your points. So if you get something that's on the outside of the original segment, then it's wrong because the weighted average should fall between the points because that would make sense because it should fall between them. Okay. And always go towards the heavier one. What's up? I have a question. Okay. So now we're going to change it because now we feel comfortable. So it says, determine the average weight of P if point X weighs 3 times as much as point Y. Right? Okay, so let's start. Let's just like start by like what we would normally write. Like, let's just call this like weight 1. We don't know it. This is weight 2. We don't know it. Let's call this X1. Where is X1 located? 2. X2 is located at 6. Okay, and now we got to figure out the weights because like we've done all we can. So it says point X weighs 3 times as much as Y. Does anybody have an idea of what we could use for our weights? Okay, but you wouldn't use the X's. We're going to multiply by 3, but we're not going to use the X's because the X's represent the location on the number line. Does anybody know a pair of numbers that I could use that would represent 3 times the amount of another number? 2 and 6. 2 and 6 would work because that's 3 times the amount of 2. Is there another pair of numbers that somebody could think about? 1 and 3, 3 and 9, 2 and 6. You can use any number because it doesn't tell you any weight. So you could literally pick a number as long as you know which one is the lighter one. The lighter one is that the one that you're picking. So since X weighs 3 times as much, this is the heavy one. This is the light one. I don't know it, so I'm going to pick any number that exists in the world because it will work out every single time. So I want you to take a second and pick a number in your head and write it down.
13.
Sure. Let's be difficult. 13 million. So you're going to put your number, and then that is going to be your Y's weight. So pick a number and put it at weight 2 because Y is lighter. So pick any number. If you want to choose a person, like maybe at your table, like all commonly like a number, so that way you guys are all using the same number, that's fine. You're going to pick a number, and then you're going to take that number and you're going to multiply by 3, and that's going to be your X's weight. So whatever number you chose at your table, so talk to your people. Pick a number. You're going to pick a number here. You're going to multiply it by 3, and you're going to put it for X.
Yeah. And I put like for weight 1.
Yeah. So pick a number for Y, and then you're multiplying by 3, and then use your formula. We should all get the same exact answer. I'm going to freeze my screen so you can't see what number I'm choosing. Continue. Pick a number. Put it at your Y. So any number in the world doesn't matter. What's up? Oh, thanks. You're all supposed to get the same number. So whatever weight you choose, the key is Y is the smaller number.
So what's your one? So I read.
Oh, it's the weight. Stop it. Okay.
You're adding the weights to the denominator.
So it's 6 plus, so.
Your Y is lighter, so you put your weight.
You said weight 14.
So Y is the lighter point. So whatever your smaller number is for your weight, that should be Y. The bigger one is that.
But it's weight 14. Okay, that's good. So we got.
X is 2 Okay, it's.
Oh, yeah.
Okay, we're mathing, we're thinking a little bit. You put, what'd you put?
Oh,
Nine. Yeah, no, I remember. Like, what is it? 6, 9, 3. It's not 11.
Okay, so you should have got what? 3. I chose a weight of 7 because I know you guys probably weren't going to use that. 7, and I multiplied it by 3, which is 21. You could have used 1 and 3, 2 and 6. You could have used 3 and 9, whatever, 4 and 12. Any combination would work as long as it is a multiple of like 3s. I would, whatever. Okay, whatever I'm trying to say. So number 5, we're going to do the same exact thing. We're going to use our big brains that I know somewhere are in your head. Okay. It says determine the average weight of P, or like average of P, whatever, if point U weighs 1/4 as much as point Z. So let's start by like listing kind of like where we're like our little weight. We have weight 1, we have weight 2, we have X1, we have X2, U is at -8. So let's kind of organize our stuff first before we start hurting our brains. It says point U weighs 1/4 as much as point Z. So what multiples should I probably be using in this case? Huh? Like multiples of what number would probably be the best? Like 2s and 4s, like 4s really, like, because you're 1/4, you're dividing by 4, okay? So does anybody think that they know a combination that you could technically use to represent point U is weighing 1/4 the amount as Z? What do you think? You can't use 2 and 4. 12 and 3 would work because 1/4 of 12 is 3. What's another combination? 8 and 2, because 1/4 of 8 is 2. What's another one? Just give me one more, somebody. 4 and 1 would work because 1/4 of 4 is 1. Okay. Now your key is the lighter one has to be the small number. Okay. So U is 1/4 as much as Z. So which one is lighter? U. So use my lighter. So let's pick, I don't know. I don't really know. You want to use 2 or you want to use 1 and 4? Let's use 1 and 4. Let's keep it easy. So if this is 1, that's my lighter one. What would Z have to be? 4, because it's 1/4 that amount. You could have used 2 and 8. You could have used 4 and 16. You could use 3 and 12. Okay, as long as U is the smaller because it's 1/4 that amount. So take a second, plug in your numbers. This one you do get a decimal, just so you know, so don't freak out if you get a decimal, it's okay. So what do we end up getting? -3.2. So if you're still working, it's okay, finish your problem. You should get -3.2 because you end up dividing -16 by 5. Like, yes, 16 is not divisible by 5, so like, that's why I like the decimals, because when we plot it back on the graph, it's just easier kind of like to eyeball it instead of being like, where would 16 divided by 5 like fall on a number line, okay? So, but if they had it obviously as a fraction, you would just have to convert it back. What's up? Like with the 1/4 aspect, or like math, because you're the one that can't, yeah.
Did 3 and 12, which is fine. So 3 and -8 is good. Plus 12 and -2. This is -24 plus -24 to add -24. Yeah. Which is -48. Do you not?
Wait, what happened?
You did, and the 24 and the 24 together.
You got it right then.
See what I mean? Like you just brought over one because you were like, they're both 24. So let's just bring over what 24 instead of adding them together. Okay. Huh? On the back, we're going to do the same thing, but on a graph. Okay. So we did this with X's. Okay. We're going to do it on a graph now. So it's not terrible. It's not terrible. It's not terrible. We like this. It's better than partitioning. So let's be happy. So it says determine the weighted average of A, B if A has a weight of 4 and B has a weight of 2. So it's the same idea, same concept. Okay. I have my weight and I have my weight for this one. So let's kind of write it out. So what is A's coordinate point? -2, 0, because you go over first. Okay. The weight that goes with that, so this is going to be x1. This is going to be y1 because it's coordinate points. Okay. And then the weight that goes with A is 4. So I'm going to say my weight 1 is 4. Underneath that, I'm going to do the same thing. I'm going to write out B. So where is B fall on my graph? 3, -5. And what is the weight that goes with it? 2. So my weight is 2. So I put all my kind of like 2's together, coordinate point 2, weight 2. I put all my coordinate point 1's and my weight 1 all together. Okay. Now I'm using just the X's and then I'm using just the Y's. So I'm going to do my X's first. So let's solve for X. So for my X, I'm using the same exact formula we just did, which is right here. I'm doing weight 1 times x1. I'm adding weight 2 times x2, and I'm dividing by the weights added together. So I'm using all the x's. So let's use weight 1, which is 4. My x1 is -2. I'm adding my second weight multiplied by its location. So I'm using 2 times 3. What would I have to divide by? 4 plus 2, because I'm adding my weights together. Still the same thing. So I'm literally using, basically, I'm using this, and I'm using this, and then I'm, of course, using the weights that go with them. So I'm just using the x's. So I have 4 times -2, which is -8. I'm adding 6, and I'm dividing by 6. So what's -8 plus 6? -2 divided by 6 is -0.3 repeating. Okay, so you could leave it as 1/3, 2/6, honestly. If you leave it as a fraction, just reduce it. So that would be 1/3, or just write it as a decimal. We're going to do the same thing for y. So this time you're using the coordinate points, you're using the weights, but you're only talking about the y's. So I'm doing the same thing, but now I'm using y1, y2, and the weights. So does anybody know what's going to be in the first set of parentheses here? Perfect. I'm adding what on the other side? 2 and -5. And then what am I dividing by? 4 plus 2, which makes 6. So then I simplify. 4 times 0 is 0. I'm adding technically -10, which is minusing 10, and I'm dividing by 6. So I have -10 over 6, which is what? -1.6 repeating. Oops. So if you put 1.7, that's fine. I just put 1.6 because it's a repeating, so you can just put the little line on top. Okay. Try number 7. Start by writing out A and B, or I guess C and D. The X's all go together, then the Y's go together. So you're basically doing the same thing, just twice. One time you're only using X's, this next time you're only using Y's. They will always give you the weight. Yes, you're only ever finding the average weight. You'll never have to like go the opposite way. So if you want to see if you plugged it in correctly, I didn't do the whole thing, but you can check where you're at. See if maybe you plugged it into X correctly. Remember, technically those top two, those first two things could be swapped. So if you have this over here and this over here, it doesn't matter because you're going to add them together anyways. But 3 should be multiplying by with 5. 1 should be multiplying with 0 for your X's because you're only using your X's. Anybody think they got the answer? They are both decimals. They're not the worst decimals, but they are decimals. They're not repeating. They're kind of cute. 0 times 1 is 0. Did you put 1? Oh, okay. Did you do 0 plus 15?
15.
Because you should do 3 times 5. Yes. Okay. X is 3.75. Does anybody feel confident enough to tell me their Y? Tell me.
Okay.
Yes. Okay. So you should have got 3.75 and negative 0.5. Because you would get negative 2/4. Now, I just confused you completely and you're like, what in the world? We were getting this and then I got confused. The good thing is on your test next week, it's not on a coordinate plane, it's a number line. So they're just giving you a number line for your test next week. Okay. So take a second, like copy what you need. You have 5 problems down at the bottom that are your homework. 2 of which are number line questions because that's what's on your test. The rest are review of what we've done so far because you do have a test. So it's like spiraling back to like practice problems from like last week. Okay. It's not terrible. It won't take super long. There is no homework or no test question like this. So if you just got confused and you got lost in the sauce, it's okay.